few more, and then we'll take a break. Right? And we do have a group activity planned for today as well. Climbing and descending. We need to consider what is my cruise altitude and what is my airport elevation. We're going to do an example of a climb here. Okay. I'm leaving an airport at a certain elevation. And I'm climbing up to a certain cruise altitude. The difference is the amount of feet to climb. I'm not always climbing from sea level, so I got to figure out what is my elevation of the airport. So then we take that feet to climb divided by the rate of climb. Very simple, gives us our minutes to climb. And when you find that problem, it's used as the basis for several different problems in the climb category. So just looking at an example here, with an airport at an elevation of 1,000 feet, going up to a cruise altitude of 9,500 feet, and using an average rate of climb of 500 feet per minute. And I'll give you a real easy one today. The time to climb, well, we first find how many feet to climb. So 9,500 minus 1,000. That will give me 8,500 feet to climb. And then divide that by 500 feet per minute. You can use your manual flight computer for that calculation. Calculator, but you'll come up with approximately 17 minutes on that. So let's take a peek. Make sure you can use that number in other calculations. Right? You might be asked, what is the distance traveled in the climb? This is the horizontal distance traveled. So you're maintaining a ground speed for a certain amount of time, and that's going to get you your horizontal distance. So that means you're going to have to find ground speed. So you're going to have to use the wind side of your flight computer in order to find your ground speed. You got to make sure you're comfortable finding that. Yeah, and we do not use ForeFlight in here for any of this sort of stuff. So don't, if you're not very strong on these calculations, you got time to get strong, right? So if we take the example from the previous slide answer, 17 minutes, and averaging 130 knots of true airspeed with the winds 160 at 24 and a true course of 190, right? We could find a ground speed of 109 knots. So you can go back after class during review and practice coming up with 109 here. So now that we have a ground speed, now we can use either a formula for time, speed, distance, or the front side of the flight computer, set our rate at 109 knots. Okay. For 17 minutes, uses 30.9 nautical miles. If you're using a calculator for 17 minutes, you have to convert it into an hour's equivalent. In that case, you divide 17 by 60. Let's go ahead and try top hat question here. There'll be multiple questions. They're all going to use the climb in minutes here. Okay? So the first part of it is going to be departing an airport at 1,500 feet mean sea level, climbing up to 12,500 feet mean sea level. What is the time to climb in minutes if we're climbing at 550 feet per minute? right, so a lot of you answered 20 minutes, and that is the correct answer there. And you ran out of time there. Right, so we are looking at 12,500 feet. Minus 1,500 feet, so you're going to climb 11,000 feet at 550 feet per minute. So we're going to use that 20 minutes for this next problem. Because we are looking for a, well, I'm sorry, in this one we're going to look for ground speed. So true course of 215. Winds are 290 at 20. A true airspeed of 135 knots. What is the ground speed? All right, so you should have found the aircraft at approximately 129 knots. Ooh. A lot of you got 128.2. Be curious to know how you got that. So we're going to use 129 on the ground speed. So all my problems are based upon 129. If you disagree with my 129, you come up after class and show me how you got your answer. All right, using time and ground speed answers, which are going to be 20 minutes and 129 knots, determine distance flown across the ground. So 20 minutes and 129 knots. Using your flight computer, you're setting your rate at 129 knots and looking for 20 minutes on the scale. Otherwise, you're using the formula, distance equals speed multiplied by time. So correct answer is 43 minutes, and most of you did find 43 minutes there. A lot of varieties in there as well. Okay. Yeah, one more on this. What is the fuel used in the climb if the flow is 23 gallons per hour? 23 gallons per hour for 20 minutes. Set your rates to 23 gallons per hour for 20 minutes. So the correct answer is 7.7 gallons of fuel used. So a lot of you got that one correct. All right, I got one more problem type to cover with you. Then we'll take our break. Okay. This one's called equal time point. This is a very valuable number to know. It would be a fix. An example would be if you're crossing over Lake Michigan. And you want to know at what point is it the same time to continue as to return. So that's what equal time point tells us. So if you are traveling over Lake Michigan, you should know if I encounter a problem with the aircraft, do I keep going straight ahead because it's time-wise closer to the shoreline, or do I turn around because the shore behind me is closer time-wise? So we have a formula that we have that the equal time point is equal to total distance between your points times ground speed home. I'll go over that, what that means, divided by ground speed total. Looking at equal time point, if we have an example of crossing, well, let me set up the formula first. We've got our home point. Okay? It could be your departure airport. It could be a fix on the lake shore. It doesn't matter what it is. We call that home, right? The other point is your destination. Setting up some terms here, we have obviously total distance between those fixes. And looking at a wind condition here, we would need to calculate the ground speed to turn around and return home, hence ground speed home, and calculate the ground speed out to our destination. Now these are ICAO terms, that's why they sound a little funny to you. This is how it's used internationally. So if I'm going to turn around and go home, that's my ground speed home. If I'm going to continue out to my destination, then that would be another term. So it's somewhere along this point here, because of the wind condition, I would have an equal time point. So I'm getting a distance here for a fix. Okay? Even though it says equal time point, my answer is not in minutes. My answer is a distance. So let's take a peek at an example. All right. Work through this together here. We're going to depart Milwaukee and land at Muskegon. So we're crossing over Lake Michigan. Our first step is to determine our ground speed home. This would be if we are turning around. You know, we departed Milwaukee, and at some point over the lake, we want to turn around and head back to Milwaukee. That's ground speed home. Now, our true course out to the destination, that means to Muskegon, is 079. So to go home, we got to use a reciprocal for that. So go ahead and calculate your ground speed home. Wind's law for 222 degrees at 21 knots. And your true airspeed is 140 knots. You should be using a true course around 259 degrees if you haven't figured that part out. Just finding the ground speed to return home to Muskegon, or to Milwaukee rather. So you should have found approximately 123 knots for your ground speed home. So you should do your best to be within 1 or 2 knots here of the answer. Now, the next part is, what is the ground speed out to my destination? So from Milwaukee to Muskegon, if you've got your flight computer, you can just simply flip around everything, get in a 079 true course. You already got your wind dot. So you should have found about 156 knots. If you're within a couple knots of that, you should be okay on this problem here. All right, so now we're using ground speed home and ground speed out. We're going to actually determine equal time point with the problem. So remember, equal time point is going to be your distance multiplied by the ground speed home divided by ground speed total. So using 123 knots for ground speed home, 156 for ground speed total. I'm sorry, for ground speed out. You should be looking around 279 knots for ground speed total.
That's tough. Don't think it's doing nothing.
All right, so yeah, we are looking at about 32.7 for the equal time point. There is a little bit of a tolerance with that of about 2.5 miles. There's a little bit of a variety of other answers there. So when we set this up, our ground speed home and out, first you'd be looking at 123 for your ground speed home times 74 and divide that by 279. And that's going to equal about 32.6, 32.7. There we go. Okay. So what we're going to do now, let you rest your brains, take a 5-minute break. When you come back into your groups. We do have time for our group activity.